Hello students, so let's try to solve one problem from IIT-JAM examination, and this is one of the very conceptual problem. And what is given that a particle is confined into one-dimensional box, and the limit of box is between minus L by 2 to plus L by 2. So this is symmetric box, and it is also given the wave function of the ground state. So we have to see that which one of the following is correct statement. So, and in that statement, we have to just check all about the uncertainty into momentum and uncertainty into position. So let's try to solve this problem. So obviously, it is given that the ground state wave function is psi x, and this psi x is equal to basically root under 2 by L cos pi x by L. Obviously, x is between minus L by 2 to plus L by 2. And this is 0 otherwise. So first we have to calculate the expectation value of x. So when we are going to calculate the expectation value of x, this is nothing but psi x, x, psi x, and obviously the normalization factor must be there, but it is normalized. So this can be written as minus L by 2 to plus L by 2 x, and you have 2 by L cos square pi x upon L dx. So we can easily see that this is odd integral, and if it is odd integral minus L by 2 to plus L by 2, that value is 100% 0. So expectation value of x is 0, and then we have to go for expectation value of x square, and this is really challenging. So what we have to do, we have to go for psi x and x square psi x, and we have to go for psi and psi, and this value is minus L by 2 to plus L by 2 x square, and we have 2 by L cos square pi x by L dx. Now this is basically even function. These are normalized, so this value is 1. So when we are going to calculate it, so this will be 2 times 0 to L by 2 x square 2 by L cos square pi x by L dx. So how you will do this integral? So you have to practice with yourself. So this integral you can do, first you have to cos square, you have to write cos square pi x by L in form of 1 minus cos 2 pi x by L, and then you have to go for integration by parts. So when you will go for that, you will get this particular number, and this is very interesting number. So that value is equal to pi square minus 6 upon 12 pi square L square. So this is your basically expectation value of x square. So when you are going to calculate expectation value of x square, you can put pi is equal to 3.14 and all this thing you are going to calculate it, and you can get this thing, but we have to find the delta x. So when we will find delta x, so this value is expectation value of x square minus expectation of x whole square, and what will happen, this value is 0, so this one is there. So we have pi square minus 6 upon 12 pi square to the power half into L. And when you will calculate this value, so this value is nothing but I have just calculated this one as in a number. So this is something approximately 0.18 L. So this is very interesting number. So this is 0.18 L. So let us check which answer can be near about for this one. So here this is delta x is equal to 0. So this is not correct. It has some finite value. Here delta x must be greater than 1 upon 2 root 3. So delta x is greater than 1 upon 2 root 3. And when you are calculating this particular value, that value is 0.288. So this is also not correct. Now delta x is between 0 and 2 root 0 and this particular 2 root 2, and that value is delta x is between 0 and 0.288. So this one is correct. So this one is correct into for delta x. This is also not correct. So according to point of view of delta x, option B can be correct. So let us try to go for delta p. So never tick answer half calculation with the half calculation. So here delta x is between 0 to L by 2 root 2. So let us try to go for calculating delta P. So this is very interesting. So when we are going to calculate delta P, so first we have to go for calculating delta P square. So I can calculate it in a very shortcut manner. Here for the particle in a box, the expectation value of energy is nothing but P square upon 2m. The expectation value of P square upon 2m. So I can easily calculate the P square. The expectation value of P square is nothing but 2m into expectation value of E. So what will be your expectation value of P square? So the expectation value of P square is 2m and it is ground state energy. So that value is equal to pi square h cut square upon 2m L square. This can be cancelled and this value is equal to pi square h cut square upon L square. Now let us try to calculate expectation value of P. And you can see the expectation value of P is 0 because your wave function is basically can be written as root 2 upon L e to the power I pi x by L. So I can write here. So this value is psi x is equal to 2 upon L e to the power I pi x upon L minus e to the power minus I pi x upon L upon 2. And what you have positive momentum from here and the same negative momentum here and the weight function is same. So expectation value of P is 0. So what will be your delta P? So from delta P, we have basically average value of P square minus average of P whole square and that value is pi h cut upon L. So now let us try to check here. So here delta P is pi h cut upon L. So this one is correct but this one is false. Here delta P is pi h cut by L. So this one is correct but this one is false. Here delta P is 2 pi h cut upon L. So this one is wrong, this one is correct. And here delta P is 0, delta x is 0, so both are wrong. So here unfortunately neither any answer is correctly matched. So what will be answer? Answer must be, I think there is typo mistake. So answer must be delta P is equal to pi h cut upon L and delta x will be between 0 to L upon 2 root 3. So this type of problem can become your exam. So what you have to do, you have to solve it properly and then you have to tick the answer. So in this type of problem, you have to just practice this type of integral. And what is this integral? That is x square sine square n pi x upon L dx or something like x square cos square n pi x upon L dx. You can go from here 0 to L or here you can go from minus L by 2 to plus L by 2. So this type of integral you have to do such that in the examination you can do it fastly. Otherwise, this is a very conceptual, straightforward question. So you have to analyze it properly. Thank you.